Good morning. Today we will look into one of the very important concept in algebra. So one of the very important concept of algebra is factoring. Many problems associated, I would say many algebraic problems has to do with factoring. So if we can factor an algebraic expression efficiently, if we know how to factor an algebraic expression, probably we will solve majority of the problems in algebra. So let's talk about factoring. By the way, factoring is the reverse process of multiplying. For example, in case of numbers, if we multiply 3 with 4, we get 12. Breaking, now if I break 12 into its factor, well, going this way is multiplication and going the way back. If I start from 12 and if I write 3 times 4 for the 12, we factored 12. Now this 3 is a factor of 12 and 4 is again a factor of 12. This same rule applies in case of algebraic expression as well. So for example, if I have, let's say, if I multiply x with x plus y, then x times x is x squared, x times y is xy. Doing this is multiplying and going back is factoring. If I go back from x squared plus xy to x times x plus y, it's called factoring. Okay, now let's look at one example of an algebraic expression and let's factor it. So consider we want to factor 18x cubed plus 27x squared. We want to factor 18x cubed plus 27x squared. In order to factor an algebraic expression, first of all, we need to factor out, well, basically we need to factor out the greatest common factor. So let's think about factoring 18 into prime factors. 18 can be written as 2 times 3 times 3. And 27 can be written as 3 times 3 times 3. I am doing prime factorization of the two numbers associated with this algebraic expression. 18 is 2 times 3 times 3 and 27 is 3 times 3 times 3. We can notice this 3 and this 3, another 3 and another 3. The two 3's, they are common factors of 18 and 21. So we could have said 18 equal to 2 times 9 and 27 equal to 3 times 9. You can notice this 9 and 9, that is the greatest common factor of 18 and 21. So in order to factor this algebraic expression, we take out the greatest common factor of the numbers, which is 9. Okay. Now x cubed means what? X cubed means x times x times x, and x square means x times x. You can notice one x is a common factor, another x is also a common factor. That means x times x is the greatest common factor of the variable part. X times x means x squared is the greatest common factor of the variable part. So we take that greatest common factor from the variable part out and we put the parenthesis around. Recall that parenthesis means parenthesis represents multiplication. Now out of 18 we already took 9 out. Recall that 18 is 2 times 9. This 9 is already taken care of. So the leftover is 2. 9 times 2 is 18. And from x cubed means x times x times x. X square means this much is already, x times x is already taken out. So 1x is left. The plus or minus, the sign remains the same. Now the same thing, out of 27, 9 is already factored out. 27 is 9 times 3, 9 is already taken care of, so the leftover is 3. Out of x square, all of the x square is taken out, so you may say the leftover is 1. It is not necessary to write 1 because 3 times 1 is only 3, so that is basically just 3. So this is the factored form. This is the factored form. Well, when we factor something, it is always good to check either our work is correct or not. Now, in order to check if this work is correct or not, so I would say check, just multiply it out. Let's do the multiplication. 9 times 2 is 18, x square times x is x to the third, plus is plus, 9 times 3 is 27, x squared is x squared. So if this expression, after I multiplied this factor form, if the expression is the same as the initial question, which is in this case, I did the correct work. So the factoring is done. So the basic idea is when we want to factor something, take out the greatest common factors of the terms in the expression. Now let's look at one more example. Let's say we want to factor this. Well, first thing we will try is as whatever we did before. Let's try to think about the greatest common factor. The number multiplying this expression is x to the third plus 4x square plus 3x plus 12. So the numbers multiplying the numbers we can see here is 1 for x cubed, 4 for x squared, 3 for x and 12 for the last constant number. The first question we have to think is there any common factor in these 4 things? And we immediately notice that 3 is a prime number, so there is no common factor between 3 and 4. In fact, there is 1, so from 1 you cannot break 1 into more factors, so there is no common factor in all these 4. In case if we look just the number. Now if we look the x, this 12 does not have any x, so we cannot factor any variable also out. So neither we can factor a number out of the 4 terms, nor we can factor the variable out from the 4 terms. So basically factoring the greatest common factor thing does not help in this question. So we don't have any greatest common factor. Well, another thing we do in such kind of expression is, well, there is nothing common in all 4. Can we make groups of 2s, group of 2 terms or 3 terms and take a common factor and factor this expression? So let us try making group of 2. So let's say I'll consider these 2 terms as a part and these 2 terms as another part. So I'm kind of making groups of 2 terms. The process of factoring by grouping terms in an expression is called factoring. Sometimes they call it factoring by grouping. So I'm using a technique in algebra called factoring by grouping. So I'm making groups and trying to factor. Well, so my first group, let's see how much is the common factor. There is a 1, there is a 4, no common factor in numbers. Now variable part, here is x to the third, here is x squared. So x squared will be the common factor. As before, we will put parenthesis around after we take the greatest common factor. From x cubed, x squared is taken out, so x is left. The sign remains the same. From 4x square, x square is taken out, so 4 is left. So the first group can be factored into two factors. One of them is x squared and the another factor is x plus 4. The first group is factored. Now let us factor the second group. Here is a 3, here is a 12. 12 can be written as 4 times 3, so 3 is the common factor. From the 3x we took out 3, that means x is left. From 12 we took out 3, that means 4 is left. Now this means, maybe we need little explanation here. Now if you look at this place, there are two terms. One term is here, there is another term. The first quantity have two factors, one is x squared, another is x plus 4. The second quantity has two factors, one is 3, another is x plus 4. So that x plus 4 is the common factor in these two quantities. So we will factor that quantity out. X plus 4 being common factor is factored out. This quantity is factored out. Again we will put parenthesis. Once the greatest common factor is factored out, we put parenthesis. Parenthesis means multiplication. Now let's look in the first quantity. First quantity is x squared times x plus 4. X plus 4 is already taken out, so the leftover is x squared. The second quantity is 3 times x plus 4. X plus 4 is already taken out, so 3 is left. So basically the factored form will be x plus 4 times x squared plus 3. Well, if we want to check this, we can do as before. So let me check. In order to check if our factoring is correct or not, we will have to multiply. Recall that multiplying and factoring, they are reverse process. So let me multiply. X multiplies with x squared to give me x cubed. X multiplies with 3 to give me 3x. 4 multiplies with x squared to give me 4x squared, and plus 4 multiplies with 3 to give me 4 times 3 is 12. So basically I will get x to the third plus 4x squared plus 3x plus 12, and this is exactly the question I was working with. So I am back to the question after multiplying. That means I did correct factoring. So two important techniques. If possible, factor the greatest common factor from all the terms in the algebraic expression, and after we take the greatest common factor, sometimes we can make groups, factor within the groups, and again take a common factor from all the groups.